The broadcast is now starting. All attendees are in listen-only mode.
Thank you for attending RSA webinar today. My name is Rafał Gawenda and I will be running today's presentations together with my colleague Artur Kosakowski. The topic of webinar is Introduction to Seismic and Spectral Analysis. You can find information about our new series of robot webinars under these links. Let me remind you about the concept of RSA webinars. We will focus on one or several topics in order to discuss issues frequently submitted to the support team. We will begin with the general introduction of selected features of the program and develop these subjects further based on the feedback we will receive from you after each of the presentations. Please mind that these webinars are not supposed to be training sessions. In this webinar, we will focus on seismic design in robot. We will cover the way how to create model and for seismic calculations, get you familiar with model and seismic cases definition, get you familiar with load to mass conversion and load combinations. And finally, we will talk about results produced by these types of analysis. In some parts of this webinar, you will find references to your codebook. For the next webinar, we will focus on the topic how to create and run code verification of user-defined section. Why and when to use spectral or seismic analysis? The main use of this analysis in robot is to describe the seismic actions on structure. In order to be able to create a seismic analysis, a model analysis must be set first. It can be done on Analysis Types window by creating new case and selecting model analysis types. What can be set in model analysis parameter? In the model analysis window, one has to specify number of modes or eigenfrequencies to be calculated. Select mass matrix. There are three types of mass matrix. Consistent. Mass is distributed uniformly along each element. Lumped with rotations. Mass is distributed only to nodes, and the rotational degrees of freedom are not considered. Lumped without rotation. Mass is distributed only to nodes, but rotational masses are not considered. For the masses, it is possible to set active directions. As a default, program automatically considers the set weight as a mass for model calculations. If one don't want to use it this way, you may use disregard density checkbox. Sturm check. The Sturm check tests whether all eigenvalues were found in the center interval or not. There are three main model analysis calculations modes. Modal mode conducts a model analysis of the structure, and in this type of analysis, Sturm check can be used. In seismic mode, Sturm check cannot be used, is not used, and seismic mode is intended for use with limits. We will talk about the limits on further slides. Seismic mode, pseudo mode, conducts a spectral and seismic analysis using the pseudo modal method. This should be used only when applying classic analysis methods based on the model decomposition results in a very long structured analysis time. There are a few model calculation algorithms. Commonly used is block subspace or subspace iterations. Block launcher's algorithm is much faster solution that had been implemented in the latest version of robot. Limits can be defined in order to automatically stop the analysis when the certain value of period or frequency or pulsation or percentage of mass participation is obtained. If one of these limits are used, the number of modes parameters is not considered anymore. Damping. This is the parameter not as treated as a damping, but as a scaling factor for response spectrum. One can include damping in calculations according to PS92 code, and damping value then will be automatically determined according the French seismic code PS92. Definition of eccentricities. This option allows user to define the accidental eccentricity of masses that one wants to consider in calculations. After setting model analysis case, now it's the time to define either spectral or seismic case. The main difference between these two approaches is the way of spectrum definition. In the seismic case, spectrum is automatically generated by the program based on selected code and input parameters required by it, whereas in the spectral case, whole response spectrum must be defined by user. Mind that seismic actions in a robot are acting along a global coordinate system of axes, so the structure should be correctly modeled to fulfill these requirements. How to prepare model for seismic design? First, design the structure under the seismic case, and then, to comply with point 4.3.17 of Eurocode 1989, concrete with reduced Young models should be used, or reduced moment of inertia instead. Modification of Young models can be done in job preferences. Loads which should be considered as masses in model and seismic calculation should be converted onto masses on the Loads to Mass Conversion tab of Analysis Types window. In fact, all the load cases are converted. It means all loads defined in a selected load case acting on selected direction from selected direction multiplied by coefficient. The conversion coefficient depends on the load nature. The coefficient should be calculated according to the code. Using formula 4.24.4 from this article, one can calculate conversion factors. So here is an example of table 4.2 from Eurocode, and on another slide, table A1.1 from Eurocode. And basing on these factors, correct conversion factor, load to mass conversion factor should be used. Damping defined in advanced parameters of model case is used as in damping correction of elastic spectra in the seismic codes where it is possible, for instance in Eurocode 8. In calculations of complete quadratic combinations CQC and double sum method, and about this you can read in the help topic. Damping defined in spectral analysis is not used directly in spectral analysis calculations. It can be treated as a sum of identifier of various spectra. It's used when preparing spectra in case of spectra interpolation. Now is the time to create a seismic case as a new case, selecting seismic type of analysis and code of your interest. List of implemented seismic codes is available in job preferences. A seismic analysis parameters window can have different view depending on selected national code. Different code, different parameters must be set. In case you need to specify values of TB, TC, and TD, the spectrum definition values, Eurocode 1998 general should be selected for calculations. Next step is to create correct combinations for getting seismic results and for design also. Let's say we have 3 levels of combinations. First level, combination between modes. According to Eurocode, CQC combination should be used. See correct settings on this slide. Second level of combinations, combinations between directions. Either SRS combinations can be used, should be activated on the left side of the direction window, or numeric combinations. One hint. Mind that only half of quadratic combinations, positive ones, will be generated. The other part will automatically be generated during the automatic code combinations generation. In case of manual combinations, the user will have to create the missing ones by himself. Third level of combination, design combinations. So, SRS or numeric combinations previously created should be combined with static cases or combinations for design purposes, either using automatic code combinations or creating them manually. Let's look at example model. So let's define first the model case. So here we have to press new button and then select model analysis type and then specify parameters as we discussed. So I will leave these parameters as the default ones. So load to mass conversion can be done on load to mass conversion tab. I will not use correct coefficient for demo purposes. I will use coefficient 1, and for our purposes I will convert both these cases onto masses. Once it is done, we can create new case, seismic case. I will select Eurocode General. Now it's time to specify all the values, but of course for demo purposes I will leave them as they are, but I will set directions, for example definition. And on directions window I will remove generation of combination in Z direction, but activate numeric combinations. Automatically you will see the code combinations between modes as set as CQC combinations. And down now, after pressing OK, simple seismic cases are generated and also combinations are shown. And now is the time to combine these combinations with static cases or static combinations. I will do it automatically, in automatic way, running automatic code combination generator. So we can select the code here. Then after pressing more, we can look at the cases. So I want to include only combinations, generated combinations. Then I will check relations if they are correct. Okay, and then generate. Of course, as usual, automatic code combinations are generated after finishing of the calculations, so we have to wait a few seconds to calculate the whole model, and then we will see generated combinations. So let's look at the combination table. I will switch the display for code combination components, and now you can see even I can filter only into seismic combination, and now we can see all combinations generated. So from the first 4 created combination by seismic case definition, additional missing ones with minus signs are generated during code combination generation. How to check results of seismic analysis? First, check model analysis results. Cumulative mass participant percentage should be over 19%. Also, minimum frequency should be checked, and total masses. All of these results can be found in a model analysis results table, which can be opened from results menu, then advanced submenu. Basing on this organigram from this slide, you can see how to act depending on the results you get from model analysis. In case of not reaching participation mass limit in a reasonable number of modes, for some codes, it is allowed to use a residual mode approach. Full explanation of this mode can be found in robot help. Mass verification. Compare sum of reactions displayed in the proper units multiplied correctly by load to mass conversion factor with the total mass results from model analysis table. In case of seismic analysis using response spectral method, results are given for quadratic combinations. When calculating quadratic combinations, the information about a result sign is lost. In robot, this information can be restored specifying main mode. In such case, quadratic combination of results are multiplied by the sign of appropriate results from selected vibration mode, the main or dominating one. Defining main mode for a specific seismic load case is the method to restore sign of the results. The sign is inherited by numeral combination containing such seismic cases. In the case of quadratic combination, it's necessary to change them into signed ones too. Generally, in the dialog below, it's impossible to activate sign combinations without quadratic ones. When planning to use signed quadratic combinations between seismic directions, it's recommended to activate it in the direction parameters of seismic analysis. In such case, more than one such combinations will be automatically generated, so it will not be necessary to manually define additional ones. Together with it, it's required to set main modes. To get correct result signs, it's required to set main modes on Combination Sign tab of Analysis Types window. Main mode should be determined looking at the model results and selecting modes with the highest mass participation factor for each direction. The use of CQC or SRSS combination depends on mode dependency, and such results for comparison of modes pulsation can be found also as a TJ or TI parameters on analysis types model results table in model results table. Graphical results such as maps, deformations, diagrams, and results tables can be displayed for a specific mode by using this drop-down menu. It is possible to display the spectral acceleration used for each mode in the model analysis results table also. All data related to the seismic spectrum can be found in the full calculation node. Calculation node can be opened from the analysis menu, then calculation node sub-menu. Let's look at our model. So after calculations, we already checked generated combination, but let's look at mode display. So I'm selecting model case. Then from this drop-down list, I can select calculated model to be displayed. And then from results menu on the diagrams for bars window, I can activate deformation to see vibration modes. Let's look again to analysis types window. Here is the combination sign tab. How to sign the combination. Let's look first at model analysis results. So I will fill the table to model case only. And now, basing on these factors, current mass in each mode, we have to select the highest percentage to determine the main mode. So in our case, the main mode for seismic results in X direction will be mode number 1. And for Y direction, we can see mode number 2 is correct. Now it's required to run calculations. Additional results can be found in model analysis results table under right-hand mouse click menu and selecting table columns. And here we can additionally display these TJ factors, eigenvectors if one is interested, sum of masses, spectral coefficients. So this can be easily added to our table. Let's look at the calculation node. So under the results in the calculation node of seismic case, we can see generated response spectrum with all parameters used to generate this spectrum. If one is interested to follow step-by-step examples how to create seismic cases, 2 examples are posted on our forum under this link. One for EC8, another for UBC97 code. Some tips and common errors you can use while looking at seismic and model analysis in robot. Mind that 3 available mass matrix do not distribute these masses in the same way. Lumped ones distribute masses on nodes, so masses affected to the support nodes are lost. You can take a try with a consistent mass matrix to make sure that the difference is due to lumped matrix. If it's the case, one can add additional nodes along the bar elements near the supports to lose smaller value of masses. In some countries like France mainland, for instance, it's allowed to disregard Z direction of the seismic action. To do so, don't disable the Z direction of masses, since this can affect determination of the eigenvalues. Apply the coefficient equal to 0 in the Z direction in the direction definition dialog box instead. Restart of the calculation. When one is in the process of reaching 90% of participating mass, it's usually needed to realize successive calculations by increasing or decreasing modes number. For big model, for which calculations usually takes time, it's recommended to use calculation restart feature in order to recalculate only the model and seismic cases instead of calculating the whole model. About the behavior factor, it's not necessary to multiply the displacement results to obtain displacement result obtained under the seismic action by the behavior factor. 0.4.444 is automatically taken into account by a robot. It is possible to save the results only for quadratic combinations, CQC or SRSs, in the file and delete the results available for individual modes. One hint: in such case, assigning combination and selecting main mode must be done before starting calculations. Mind that if this checkbox is checked, then the one will be able to obtain results under quadratic combinations only for type of results that are checked in the green framed area on the screen. For the other results, like von Mises stresses that are calculated only when the user asks for the display, the software will not be able to make the quadratic sum since the results for the individual modes had been deleted. How to obtain base shear force? Either one can look at the sum of reactions in reactions table in the Z direction, or it's presented for some selected codes for which base shear is required to be calculated. This value is presented in calculation node. It is also possible to create static case from several static forces. To do so, it's needed to open pseudostatic force table and then from the right hand side mouse menu select pseudostatic force to static case option. Then after selecting load case and the mode, program will automatically convert pseudostatic forces onto simple forces in static case. This can be also done by API tool, which is posted on our forum. It is not possible to obtain rotational bending moment at the bottom of the building directly from robot. It must be calculated based on the sum of the reactions with these assumptions and using such formulas. We also created the Excel macro calculating this using the data which can be retrieved from robot automatically. The link to this macro you can find on this slide. Some additional hints. Once again, a small reminder about signing combinations. Be aware of selecting main modes for seismic combinations calculations. It may happen that you may see during model analysis calculations error 3060. This error cannot be disregarded. Usually, model analysis diverges and it's reported by the program. It is caused by ignoring instability in static load cases. To solve this problem, it's needed to correct model to get rid of instabilities in it. Sometimes error 500 may appear. It's related to excessive value of mass eccentricities. In such case, it's recommended to check if the values of eccentricities are correctly defined. Nonlinear seismic. In the case of nonlinear properties, such objects are resulting nonlinear behavior of the structure. In such case, vibrations are nonlinear. They are not harmonic, but spectral and seismic analysis are based on assumptions of harmonic vibration. It is so because the stiffness of the structure can be changing during vibrations. Dynamic model analysis is a linear analysis assuming constant stiffness of the structure. In case of nonlinear model, the dynamic model analysis is run for a linearized model, assuming constant stiffness resulting from the static load case preceding given model load case. The precise approach for nonlinear seismic analysis is using the nonlinear time history analysis. It is possible, but it is necessary to input time history function of ground motion. Theoretical basis how to calculate ground time history function of ground motion can be found on web, and also the example software generating such function. Nonlinear time history is a type of analysis requiring significant hardware resources and requiring a long time of calculations. During model calculations, such message can be displayed: number of missing eigenvalues found. And it is displayed when there are multiple similar eigenvalues corresponding usually to local vibration of some part of the structure. In such case, it may happen that during iterations, the order of such eigenvalues is changing, and eigenvalues which were originally in the range of the calculated ones will no longer be in this range. This message is reported by Sturm check sequence. And pressing no on this window, one is forcing program to finish model analysis and pass to next load case. Pressing yes means increasing range of calculation of eigenvalues to find all missing eigenvalues. When we press escape, it is kind of hitting several times yes button and allows program to automatically find all missing values. It may happen that such calculations may take a long time. There are some additional resources, there are some additional documents or videos related to seismic analysis in a robot available on web. You can follow these links. All these materials shown on the slides are available, but only in French language. Seizing the opportunity, I would like to introduce to you the Autodesk Knowledge Network site, where you can find useful articles on the topics covered during this webinar, as well as on many others.
So thank you, Rafał, for the very useful information covered during this webinar. So I think that was very helpful for many of us to understand the principles and the technique to define seismic analysis. And now we will try to answer questions. So please ask them. We will handle as many of them as possible. For the ones that we are not able to answer right now, we'll encourage you to go to Robot Forum and post them. For the one that we already have, was like how, in the situation when you convert only few live load cases into masses for seismic analysis, how to make sure that only those live load cases are included during automatic generation of combinations. So I think the easiest way is to use manual automatic generation of manual combinations. Then you can mark the load cases that you want to use, meaning that you may disregard the live load cases that you want to exclude. And then you can generate the first set of manual combinations, and then repeat these steps for different selection of load cases, creating different groups of combinations for ULS, SLS, accidental, or seismic combinations.
As usual, we have kind of the off-topic question about the availability of the video and presentation. Yes, as usual, the video will be posted on YouTube and available on our playlist in a few days' time, and the same the presentation will be posted, and the link to this presentation will be published on our forum.
Yep, there is another question about the content, the range of today's presentation. Yes, this is only intended to show how to define seismic analysis, how to create combinations. This is not including the design for seismic load cases. That's maybe a good suggestion for another webinar, but this is not the area that we will focus today.
There's a question about the additional materials. If you experience the problems with the links we posted, we will change the links or check the links and post them on the forum again. This is the question about the difference between global and dynamic mass. Let's look at the analysis types window. So while converting load to masses, we can select different types of masses. Either they can be dynamic or global, or for selected model case. The difference between them is that if we select one certain, let's say, model case, the converted masses will be acting only in such case. If we select dynamic mass, it means if we have more than one modal case, such converted masses will be acting in all dynamic masses. And global masses parameter means that the mass will be used in all dynamic cases, and additionally, if one has inertia forces, inertia cases, such mass can be also used in inertia forces calculations. So the questions about signing combination. So once again, how to sign the combination. First we have to look at model results and determine. Sorry, not this one. Model results. So I'm opening now model analysis results table and select it only to display the model case. And now looking at the current masses, let's say we are aware only of ux and the uy direction. So only in these two directions we have to find the dominant modes. So in our case, dominant mode means the mode with the highest percentage of mass. So for this model, we can see the highest percentage is for mode 1 in direction x and mode 2 in direction y. So that's why there was the reason I specify for x direction main mode as a mode 1 and for y direction main mode as a mode 2. So once again, our slide about signing combinations, signing and defining a main mode. As you can see on the screenshot on the right hand side, on the top you can see default results for quadratic combinations. So as you may see on the diagrams, the results, the sign of the results is the same. But if we use signing combination, correct diagram based on the sign of seismic cases will be generated. So not only positive values will be presented.
A repeated question about how to deal with the situation that we have part of the structure that we do not want to consider its mass in seismic analysis, or part of the structure that is underground. I think that one of the approach that you may actually do is set disregard density in the model analysis parameters, then create a new load case when you apply self-weight only to this part of the model that you want to include into seismic analysis as a mass, and then finally converted such created load case into mass. There is another question about The question about varying Young modulus during cyclic loadings. So in robot, there is only one value of material properties used during the calculations. And as Rafał indicated, you may reduce that, for example, for concrete to take into account that it actually cracks, but there is no change of the value at different stages of analysis.
So here you can see the relevant slide of my presentation.
And there's another one, and basically it is when you want to run a seismic analysis or spectral analysis with different factors, with different parameters. So in this case, you may need to create several different load cases with different parameters and then use them, for example, for SLS or ULS check.
There is a question about the availability of seismic codes. So as I mentioned, all the seismic codes which are implemented, you can find the name of them in job preferences. So when I open job preferences under design of codes, loads, here you can see the item for selecting design calculation seismic code. There is a short list. If you press more, you can see all available national codes for seismic design.
I think that, again, that there is a repeated question about load to mass conversion, about different options to select them. So let me explain that you may assign that to a particular model case. You may assign them to all dynamic cases defined in the example, and you may also use the global one, which includes also inertia forces. So imaginary situation is that you have a vessel and you put some kind of structure on that, and well, as it sways, it generates inertia forces. So this global mass will also be included in the calculation of the forces generated by this rotation of a vessel in this example. And if you assign loads converted to a particular model case, you may create several different types of analysis with different parameters. So, for example, you may see the difference that the situation that I described, that you exclude certain part of the model from mass, defining the self-weight on part of it. You may assign that to one model case and create another model case with the conversion of the entire self-weight and compare the results and see what difference this makes to decide which option is better.
So there is a question about the pseudostatic forces and how to convert them. So I will show this procedure. So first we have to open pseudostatic force table, and we can see results for example, for selected cases, for selected modes, see generated calculated forces, and on the right-hand mouse click, we can select the option pseudostatic force to static case. Then new window appears. Now we have to select the load case, the mode. So let's use the first mode with the significant number mass participation factor in x direction in our case. Okay. And now new additional case is created. Forces, so we can see it in the load table. So all the pseudostatic forces are converted as onto nodal forces.
There's another question about difference between creating separately model case followed by seismic or spectral, or using the wizard model with automatic definition of seismic cases. There is no difference. Finally, using all approach, you end up with exactly the same load cases. It is simply the different way of defining them. The latter option was introduced because it was found that this may be not easy to understand when you start working with the software, that you need to define model analysis first to be able to access definition of spectral seismic case. So therefore, this is another way of defining exactly the same cases. So basically there is no difference, only the sequence of actions is different.
The question about the selecting method of mass matrix for model. Once again, in model definition, you can see three types of mass matrix: consistent, lumped, and lumped without rotations. As a default, program uses lumped with rotations, but usually we can disregard rotation of masses, the actions of rotations, and use lumped without rotation. More time-consuming calculation you can have, and a little bit more exact if you use consistent mass matrix. So the best way, as was mentioned during the presentation, is to compare calculated masses, used masses in the model. If they are in reasonable range, we don't have to play with the masses. If not, either we can change mass matrix types, for example, auto consistent, or additional kind of division nodes on some bars near the supports to lose smaller number of masses by converting them onto nodal supports. The question about the reduction stiffness according to Eurocode 8 in job preferences. In fact, what we mentioned in our slide is reducing young modulus. Reduction means creating new material and specifying different young modulus. Of course, afterwards, such young modulus should be assigned to objects, elements on our structure. So this is one way. Another way, as I mentioned during the presentation, is reducing the stiffness by reducing stiffness by changing stiffness factors from one to different in the definition, for example, of here you can see the reduction factors. There are two ways to obtain any behavior of reduction of stiffness. So we are running out of time. So if there are some unanswered questions still on our question box, please post them on our forum. We will try to answer them as soon as possible. And now I would like to thank you for attending this webinar and invite you for the next one, which will be held on 7th of October. And the topic of this webinar will be how to create and run code verification for a user-defined sanction. Thank you once again for attending today's webinar.